Today we're going to cover the vectors. Vectors can be new to you because it has its own algebraic ways of adding and subtracting, but if you have strong understandings and basic concepts, you'll do well in vectors. So let's get started. First, you have to know the definition of scalar and vector. A scalar is a quantity which has only magnitude, such as distance or time. Vector is a quantity which has both direction and magnitude. So to draw the vectors, you have 2 points, O and A. O is usually an origin, and A is just another point. So you draw a arrow connecting O and A because the direction is important. So you denote it as OA with the arrow or arrow on the above, or just a bold A. Usually when you write this, you can't write bold, so you just have to go with the OA with the arrow above. When you denote the magnitude, you put the absolute value sign, or you call the modulus. When two vectors are equal, they have the same magnitude and direction. So wherever they are, if they have same magnitude and direction, they're equal. So all these 3A vectors are equal vectors. There's something called zero vector, which is a vector of length of 0, and it's the only vector with no direction. When you have negative vector, well, first, when you have a vector AB and you take the negative, it becomes the opposite way. It becomes the BA vector. So when you put the opposite on a vector, you just have to flip the direction around. When you add the vectors, the pointy side of a vector is called its head, and the other side is called the tail. So when you add the vectors, you have to connect the tail and head. So when you're doing A plus B, you're connecting the head of A and the tail of B. And if you do the other way around, like connecting the head of B with the tail of A, it just gives the same vector. When you do the vector subtraction, you have to flip one, like if you do A minus B, you have to flip B and make minus B and then add them. A vector can be expressed in component form. If you put the vector on the coordinate, it has x component and y component. So you count the x-axis and y-axis, and you put it in the parentheses. So equal vectors in coordinate form. So when you have p, q, and rs vector, you have when you have p equals r and q equals s, you have the same vectors. When you add them, you just have to add them inside the parentheses. Like to add a and b, if the x component of a is a1 and y component is a2, and x component of b is b1 and y component is b2, you just have to do a1 plus b1 and a2 plus b2. The negative vector for this is just negative on the components, so you can do the subtraction with this also. Zero vector in component form is just 0, 0. Magnitude of vector, which is modulus A, is when you have the component form, you can calculate the actual magnitude. When you have A with the x component of A1 and y component of A2, you can do the square root of a1 squared plus a2 squared to get the modulus a. The parallel vectors, a is parallel to b when a equals kb, and k is not equal to 0 and is a scalar. So basically, when some vector is the constant multiple of another vector, then those two are parallel.